The climate is warming and the Greenland ice sheet is melting faster and faster. Some parts of the ice sheet are producing 50% more meltwater now than they did in the mid-90s. Sea level is rising at about 3 millimetres per year, and about 1 millimetre per year of this rise comes from Greenland. My name is Martin Tranter. I'm the principal investigator of the Black and Bloom project. Satellite images have shown that parts of the ice sheet surface have been darkening over the last 20 years. Darker ice surfaces melt faster than brighter, whiter ones. So Black and Bloom aims to understand just why the ice sheet surface is darkening. Is there more dark dust melting out of the ice? Is there more black soot being deposited onto the ice? Are there bigger, darker ice crystals growing in the warmer surface ice? Or are there dark ice algae blooming over the ice sheet surface? Our microbiologists are taking samples to work out how much algae is growing in the ice and what controls the dark pigments they contain to prevent them being sunburnt alive by the strong 24 hours a day of sunlight. Our atmospheric chemists have put a number of sensors onto a tower to work out how much dark dust and black carbon is in the air. We are collecting ice cores because we want to know if there are dark particles melting out of the ice. Every day, members of our team walk several kilometres around our campsite, stopping every 5 minutes or so to measure the darkness of the ice surface. This gives us a great idea of how the ice surface darkens during the melt season. We fly drones with special cameras to get more of a bird's eye view of how the ice surface is darkening. The camera sensor captures the same light spectra as satellites flying overhead, and so we can link our measurements on and near the ground to those captured from space. We want to extrapolate the measurements from our field site across the whole of the Greenland ice sheet. We will couple the variations in colours we measure to those observed by satellite to map out the distribution of algae, soot and dust across the whole ice sheet. We aim to produce a better surface darkening model that can be fitted into our current surface melt models. This will enable us to better calculate how much the ice sheet will melt over the coming decades. Ultimately, it will allow us to project sea level rise into the next century.